Good morning. Here we go. We're going to dive into chapter 5 now. And you definitely want a calculator handy because we'll be doing a lot of work with rates. And we'll go from there. All right. So grab your note sheet and away we go. First thing we need to talk about is what is a ratio. And a ratio in math, I guess the most common way that we see it is when we write it as a fraction. Okay, a fraction. But what is a fraction? Well, it's basically a math term or an expression where we're comparing two numbers. We usually have a numerator and a denominator. And this is how we define what a ratio is. We're comparing two numbers to each other. We most often see them written as a fraction. So let's say something like 3/4. Okay, we'll write it this way. But you could also see it written in other ways, especially in different types of word problems. You might see it written in words, where we write it this way, 3/4. Or sometimes you might see this notation using a colon, like this, 3/4 this way. All of these really mean the same thing as we're comparing two quantities to each other. And this is what we're going to work on and get familiar with today as we build into the rest of this chapter. All right, so let's go to my favorite topic in the whole world, which are M&Ms. And let's say you get this nice pack of M&Ms, and of course you dump them all out and you analyze them because weird people like me tend to want to separate the colors and kind of look at how they're arranged or what quantities you've got of each one. So in this particular bag we have 7 red ones, 9 brown. Don't you always have the most of brown? Yeah. 6 of them are orange, 3 of them are green, 5 are blue, and 2 are yellow. So just so you get the idea of this, and I ask you, all right, what is the ratio of blue M&Ms to brown ones? You just pile through the information here, and I would say, well, there's 5 blue, and there were 9 brown. And you can write your answer as a fraction. That's kind of how us math people tend to do it. We could also write it in words, 5 to 9, or we could use the colon notation and write it 5 to 9 this way. All of these answers are perfectly fine. Next one, blue to all. Blue to all. So I go back and I say, well, there were 5 blue, and there were 32 all. So you could write it as the fraction 5/32. You could write it in words, 5 to 9. You could write it with the colon, 5 to 9 this way. All right, let's look at these last two. Yellow to all. All right, as I pile through my list here, I see I had 2 yellow. 2 to all. 2 to 32. Oh, right now, I hope that your algebra antenna are firing. Beep, 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 beep. Because you see 2 to 32, and you've been so trained all these years to say, you know, this is a good fraction and everything, but it's really not in simplest form. I've been trained to put things in simplest form, and I can say, you know, 2/32, that's really also the same as 1/16. So what we need to train ourselves to see is that if you happen to write this ratio this way, 2 to 32, that it also is equivalent to 1 to 16. And it's most obvious when we write it as a fraction. It might not always be as obvious when we're writing it in a different notation. Or if we all of a sudden use the words down here and said 2 to 32 this way, that this also means it's equivalent to 1 to 16. All right, the last one here, yellow to orange. I have 2 yellow. Oops, let me get my ink back on here. Yellow to orange would be 2 yellows, and there were 6 orange. 2 to 6 here again, we should make sure we put that in simplest form. Typically, we go like this. So 2/6 is the same as 1/3, or 2 to 6, 1 to 3. And again, you could write this in this way, or you could write it in words, and it's all the same. Okay? All right, now, the other word you're going to see a lot in this chapter, and most of the 7th grade standards emphasize this a lot, is a proportion. You've heard this word before, and I want to talk through what you've seen about this before. A proportion is really some sort of math statement, and it always has an equal sign. All right, so the first thing I want to make sure you understand is that it's an equation, and it's an equation of two fractions, two ratios, okay? Two fractions or two ratios, and they're equal to each other, okay? Two fractions that are equal. So, just like I had in that last one, 2/6, that is the same as this fraction, 1/3, okay? They're equivalent fractions. Or if I had something like 3/4, and I said, hey, can you think of another fraction that's equal to this one? And you could say, well, let's see here. I know that I could, this is already in simplest form, so if I kind of work the other way to come up with something that's equivalent, I know that if I multiply numerator and denominator by the same value, I could come over here and say that's the same as 6/8, for example. Or I could say 3/4 is the same as, like 30 over 40, or 15 over 20. There's so many possibilities. You can just come up with an infinite number of possible other fractions that are equal. All right, some of the problems in your assignment today are going to ask you questions like this. Here's a fraction, or a ratio, I should say, and the directions are, can you give me two ratios that are equivalent to this one? So I'm asking you come up with a fraction that's equal to 9/27. Now, looking at your calculator or simply looking at this, you could say, hey, this thing isn't in simplest form. I know that in looking at this, each of these have a factor of 3 in there, for example. And so maybe I want to say that this is the same as 3/9. Exactly right. There's a fraction that's equivalent to that. I can also keep going with this one and say, you know what? It's also equal to 1/3, because 3/9 also has factors of 3 in the numerator and denominator. And you could even go bigger in the sense that instead of dividing and getting it in simplest form, you could start multiplying by something. So for example, for 1/3, I could multiply top and the bottom by 10 and get 10 over 30. Or take that 9/27 and say 90 over 270. The possibilities are endless. You just come up with two that work. Look at this second example, 64 over 24, that ratio. Well, gosh, I look at these and I say, man, both of these are even numbers. So I know if I divide both of these by 2, I would get something like 32 over 12. That's equivalent to this one. So if I kept going here, 16 over 6, or 8 over 3. Now I'm finally in simplest form there. Just two possibilities that work. The other thing that you're going to be asked to do in your assignment is to say, here are two fractions, and can you tell me if these actually form a proportion? So when you look at something like 3/27 and 2/18, what I'm asking you is, are these guys really equal? Well, there are two ways, or actually 3 ways you could probably go about deciding this. One would be to put each of these in simplest form. And when I do that, 3/27 is the same as 1/9. 2/18 is the same as 1/9. Yes, indeed, they are equal, and I would answer yes. But let me show you another way, which we're going to utilize a lot as we get more into solving proportions. There's this neat property that says if you really have a proportion, that the cross products are equal to each other. And what I'm going to do is change color here so you can see what I'm talking about. I'm saying that if these really are equal, the numerator 3 and the denominator and the other fraction, 3 and 18, when I multiply those, always are equal to the other combination of that denominator and this numerator. If these are equal, it's a proportion. When you multiply these, and you can check on your calculator if you need to, this is 54. 27 times 2 is 54. Since these are equal, yes, this is a proportion. In fact, they are equal. If I look at this one particularly down here, I could check it this way and say 12 times 36. Grab your calculator and check that one. And 15 and 27 is the other cross product. 15 times 27. When you take these two values and check them, here's what happens. 12 times 36, oops, as I'm checking on mine, I get 432 on this side for this value, 432. Over here, 15 times 27, already I'm skeptical because I know when I take a 5 and a 7, it's going to end in a 5. This I get 405. These are not equal to each other, which tells me it's not a proportion. Okay? Or I could take 12/15 as a fraction, knowing that each of these has a factor of 3 in them, and get it in simplest form. 12/15 is the same as 4/5 in simplest form. This guy, actually 27 and 36 share a common factor of 9. And if I take that factor out of there, this is actually the fraction 3/4 in simplest form. Nope. These guys are not equivalent to each other and do not make a proportion. So these are the two skills that you'll be working on today. And I'm going to zip through some of the rest of this. And what I assigned for you in your assignment, I shortened it up because we were running a little short of time. So on page 218 in your textbook, look at problems 11 through 21 and be ready to get that corrected. Good luck.